Hello everyone. Welcome to Cedar Lighthouse Project Season 2, the power of graph convolution networks, master graph-based machine learning. Myself, your host, Roopesh Bharatwaj K R. Let's go to today's session. So now we are in like a week 5 and ninth class. So we're going to talk about the attacks on graph neural networks. As usual, let's start with like a small recap from our last session. Session we did discuss about like what is large language model and what all the different types of language models are currently is used in our markets, and what are the different types of models we have, and how to do a fine tuning of large language model by choosing an exact pre-trained model. Either it can be like a GPT-4 or 3, or like Pama from our Google, or Llama from Meta, or any other Hugging Face existing large language models. And then we'll be preparing our data set, and we'll be defining based on our task. Then next step is like we're going to do like a tokenization for that, and we'll be doing like tuning our model architecture, mostly in our last layer of the algorithm. So we're gonna tune that. And finally, we're gonna do like a training and evaluation based on our data set. And that's how a fine tuning of LLM is being done. So we all aware like there are different types of LLM currently in market, like Google's like a Lambda is there, and Pama is there, and Meta's Llama is there, and OpenAI's GPT-4 is there. So these are all being trained using like different parameters. So if you consider like GPT-4 is being trained by 1 trillion parameters, and GPT-3 and 3.5 is being trained by 175 billion parameters. Same for like a Google's Pama as well, which has like 540 billion parameters, much more sophisticated than ChatGPT or GPT-3 and 4. So we did discuss about like in basic of like what's the different types of LLM and what are the current market of LLM. So then we did talk about like what's a LangChain. So basically, LangChain is like a framework. It's being developed for developing applications using LLMs. And we were asked to there was this last session was like a mix of lab plus a lecture session. Same, we're gonna have the same right now. So we did talk about like what are the Python drivers available there for like Neo4j, and how to connect with our Neo4j using a Python, and then installing packages of like our Neo4j, and then installing packages using like a LangChain. And in today's session, so we're gonna talk in a brief about like what is attack, and what is the attack, different types of attacks for like graph neural networks, and what all the defense mechanism available for graph neural networks, and what all the impacts of the attacks. And finally, there we're gonna have like a session as well. So where we'll be working with like developing our board, which integrates with our large language model using a LangChain concept, and we're gonna integrate with our Neo4j, so that we're gonna have a chat and discussion about what's exact query is that, and how to retrieve the query from our Python module. So let's jump into what is attacks. So we all aware that the attacks is a kind of like a malicious activity is being done. So that's the same thing happens in our graph neural networks. So these are the attacks which are mainly a type of adversarial attacks that aim to manipulate the behavior of a graph neural network model by crafting malicious inputs. So basically, our inputs, if it has like some malicious or like Trojan based inputs, that in like made as like a node or like a edge, then that makes the model to predict incorrectly, and it compromises the privacy of the data and the data used for training as well. So completely, it's going to show us like a negative predictions completely. So that's the basic understanding of attacks. So in this like image, you can see there's like a poison node U. It's being connected with our different nodes. When there is like a node defense mechanism is there, so obviously the U is directly connected with another couple of nodes, and it predicts based on the malicious inputs. But if we have a mechanism, a watching mechanism or like a monitoring mechanism, which can guard our attacks. So basically, GNN guard is like a model, so which used to protect the malicious activities and everything. So that's the way how it's being protected using a malicious activities. And then whatever, irrespective of the malicious activity, our node or the algorithm, which is to be predicted correctly, 100% it will do like correct predictions. So that's the basic aim of like adversarial attacks of graph neural network. So basically, they are like two different types of GNN attacks being is there. So what one is like the attacks is based on like data poisoning and the attacks on backdoor. So these are like two different types of attacks right now. So basically, what is a data poisoning attack? So data poisoning attack is like injecting a poison or like a Trojan basically into a training set of the GNN model. So since that's like a Trojan is being loaded in the GNN model, the malicious activity of the data can then cause the model to learn incorrect patterns and which can lead to like complete disastrous prediction. So which is supposed to not predict correctly, and it makes like completely complicated of the model, and it loses the trustability and the privacy concerns of the model. So that's the data poisoning attack. The next one is the backdoor attacks. So backdoor attack is nothing but inserting like a hidden trigger. Basically, hidden trigger is inserted into the model that can be activated by an attacker. So that attacker can activate at any time when it is like inserted into the model. So this attack can be used to cause the model to make incorrect predictions, and also it compromises the privacy concerns of the data which is being trained by the model. And basically, when GNN attacks are considered much more serious threat to security and privacy of graph-based applications, because it is important to develop defense against these attacks in order to protect applications that being caused by this harmfulness. Why? Because the GNN are the basic architectures which has been used for recommendation systems and a lot of application modules and everything. If this model has been compromised, that means like it's easily it is attacking the privacy concerns of the users. So when the users are being attacked by this Trojan, so the attackers or like hackers, they will have the control of like a different data types being used by the users in like public domain or e-commerce websites. So it is important to have like a backdoor mechanism or defense mechanism to protect the graph neural networks being attacked. So this is the basic of background of backdoor attacks. So that is like another thing also to mention. So backdoor attacks in GNN are like a types of like adversarial attack. As we know, they are inserted as into a model, and which allows an attacker to manipulate the model's behavior. So now the model's behavior is completely under control of an attacker. So whatever he has in his mind, he can do that for that. Once the backdoor is placed, so he can inject this model into like another subgraphs as well, and he can completely infect the entire graph of the recommendation system. So once the entire graph is being like compromised, so that means like that's the situation where like we have lost the control of our entire system. So it's like likely to be happen when there's like no defense mechanism is there. So that's the important thing. Like we need to like safeguard our the triggers before it's being like operated, or like a trojans. We need to have like a multiple checking mechanisms is there, monitoring mechanism is there for our graph neural networks. And one more thing, this is not only particular for graph neural networks, it is can be applicable for like any other machine learning algorithms as well, and also like a normal neural network algorithms as well for attacks on backdoor. So the backdoor attacks are being considered in like two different types. So mainly they are like subgraph based backdoor attacks and node based backdoor attacks. So subgraph based attacks, these are the attacks which inject a specific set of subgraphs. So this is like a subgraph based door. So here we have the attacker here, and once we have like an entire graph, the attacker creates his own subgraph. So that subgraph contains a trigger in it. So once this trigger is being activated, and now the backdoor or our machine learning model is being compromised. So here the subgraph is designed by a hacker in a way that it is not easily able to like detect. So it will be making like it will be looking like alike our main graph, and there will be no much of like a difference between the original graph and the created graph of the attacker. So that's the biggest like a key point here, how attacker is being done. So there's another like a different type of backdoor attack. So that is called like a node-based backdoor attack. So these are attacks when a specific pattern is being injected into the main graph, or a specific set of nodes in the input graph is being made. And this pattern can be a combination of nodes, or it can be like a features, or it can be like connections between any nodes. So here you can see there's like a specific set of patterns here. So which we can't relate, like either it's going to be like a original graph or it's been like a constructed graph. So we are not sure how it is. So here the attacker designs this pattern, and it is like completely like difficult to understand the difference between like whether it's like a normal graph or like it's a generated graph or like a triggered graph in it based on the specific set of patterns. And then it's being compromised once it's like fed into the model. So let's jump into the different types of examples of a backdoor model. So like the one biggest example of like a backdoor attack of JNN is like poisoning the training data. So as we all aware, like what's the poisoning of a training data? That's nothing but like a attacker injects a malicious data into the training set and causing the JNN model to learn associated background trigger within a specific set of labels, and it doesn't know like what's like your future labels is there. So it doesn't know the edges and representations. So it's completely based on the poison the data the model is being trained. So next important thing is like embedding a trigger. So once we embed a trigger in the model parameter, and then attacker can modify the model's hyperparameters directly by incorporating the background triggers. So this is kind of like a more difficult attack to detect, because like we are not sure like how the parameter is being modified or is being like automatically changed. So that's how the way the hackers have written the code that can trigger a model which we all set to default values, which can trigger automatically based on that the data which is being implanted by the hacker, and the hyperparameters are completely changed. So when a hyperparameter is completely changed, then we don't have the control over the model performance and everything. So that means like we have been completely compromised with the data, irrespective of like a different like a good quality of data or anything. When a model is being touched, the model is nothing but it's a heart of our machine learning. So once it is being disrupted, that means like we have like completely compromised with our the model prediction. So that's the one of the thing of main thing where hackers do in today's world. So we all aware like different types of attacks right now. So let's talk about how are a different defense mechanisms is being done for like background attacks. So let's jump onto it. So they are like a different methods to like a detect if there is like a background attack is being done or not. So one of the method is called like a data sanitization. So the data sanitation is like where we'll be cleaning the data completely from like A to Z, and we'll be finding if there's like a potential malicious data points are being connected with different edges or nodes, and thereby we'll be having like complete routine of checks and the monitoring patterns of data which we have. So that's the important thing for like a basic level of defense mechanism, I would say. So next is like a model introspection. So here we'll be analyzing the model's behavior. Here basically we'll be analyzing the model's behavior to identify is there like any anomalies or like a different set of patterns there that could indicate the backdoor attack is being formally attacked or not. So that's the way of like integration, integration with our models. So we'll be having a continuous mechanism of checking of models is like how is being done. So is there like any change in the parameters or not? Is there like sudden anomaly has arisen or not? Or there is like any patterns within the data and which causes such a trigger in between of a model running in different epochs or not? So that's the biggest thing. And next one is like called like a certification. So here, like certification is like it's a basic of like a formally proving that a model is not directly compromised to a backdoor attack. That's the kind of like certifications we need to give to a model, whether it's being compromised or not. It's being compromised based on a specific set of data and the way we train it. And after finding the different patterns and everything, and then finally we'll be satisfied that the model has not been compromised and it can be like a moved into production level. So think of a situation like when like the computer vision algorithm is being run in like a Tesla car. So what if like a malicious actor, like hackers or attackers, they wanted to do like a tuning of the model in between the car is being run. That means like the car will be following the different lane routes. So when there's like a sudden attack in between of the travel, that means the lane automatically changes into the opposite side of the lane and which causes like potential accident. So these are all the latest thing. So we need to consider right from the data cleaning process and to the model interpretation, model interface, and finding the parameters and it's being compromised or not, and finally giving a certification for the model so that like it will be like the privacy concerns or the data concerns or safety concerns is being met or not. We can understand. So these are like a couple of types of like different mechanisms is being done. So next important thing is like in detail, if we gonna speak about is called like a input validation. So input validation is kind of like a checking the graph like a input. Is there like any different kind of suspicious pattern is there or not, or like there's like an anomaly is there or not? And if there is like a specific set of trigger is for like a potential backdoor trigger is there or not is being checked here. So this can be done using like a couple of testing mechanisms called like a isomorphism check or the subgraph level pattern matching checking or like a graph anomaly detection checking. So finally, by scrutinizing these inputs, the likelihood of backdoor activation can be reduced completely. That's the important thing of like input validation here. So next important thing is like a model monitoring. So we did talk about like a bit of a model monitoring in a previous step. So here the model monitoring where we'll be continuously monitoring the model's performance. So from like complete like at the time of like training, the complete monitoring will be done in order to like detect if there's like a deviations from the expected behavior or not, or is there like any errors which are suddenly arising or not. So it is easily possible for us to track whether like based on logs and everything. So they are like a different set of techniques for this call, like anomaly detection is there, the performance matrices tracking is there. So and they are like a explainably different methods also be there. So by finding the anomalies in the model output, the potential backdoor can be promptly addressed here. So there's like another method called like adversarial training. So in this methodology, the GNN model on a set data set that indicates the adversarial examples, for example, specifically crafted to find the triggers in a backdoor. So this process helps the model to develop a complete robustness against a different set of attacks, and then it learns by itself and resists the backdoor activities which is being attempted. So that's called like an adversarial training, where we'll be giving a set of trainings so that the model is like a much more in like a, enough to understand what's being like given in the model's input, and then it can train by itself, and like it prevent from like a backdoor attack, different types of attempts as well. So next is like a graph transformation techniques. So in the graph transformation techniques, which involves the transforming the input graph before feeding them into a GNN model. So this can be done using a technique called like a graph pruning. So the graph simplification and graph sanitization we already discussed. By modifying the graph structure, the vulnerability of the graph, like a backdoor activation, can be completely reduced. So that's the important feature of the graph transformation technique. So next important thing is like ensemble learning. So that's like in ensemble learning, which involves the combination of multiple GNN models with the different architectures or different hyperparameter tuning, can mitigate the impact of backdoor attacks. For example, a single compromised model may not significantly affect the overall prediction. Why? Because since we have like a multiple models running in parallelly, if one model is being attacked, the other couple of the model is being saved. So that means like one model is attacked and like another models are not attacked. That means there will be no that much of implications. But still, attack is an attack. Like we need to do like a set of like a matrices or like a set of like a safeguarding features. We need to do that. But on overall an ensemble learning, that's approach which can which uses like a multiple models running at a time. Even if one model had been attacked or compromised, the other model can be safeguard you. So that's the concept of ensemble learning. So the next one is called like a trusted computing environments. So so in a trusted computing environment, when the general model is being deployed, here, the trusted computing environment, such as like set of like hardwares or like a secured enclaves or the security modules, can provide additional protection features against the backdoor effect of triggers or like hackers. So these environment isolate the model's execution and make it more difficult for attackers to manipulate the model's behavior, irrespective of the complexity of the attacks. So here, like we will be having an extended safeguard by using the environment, different hardwares. So these hardwares protect our models against the like malicious activities by the hackers or the potential hackers code which can even manipulate the model's behavior. That also being not possible with the trusted environments or like a set of hardwares. So this is also one of like a model way of preventing malicious activities to be attacked from our model. So next important thing is like transparent and verifiable AI. So in a transparent and verifiable AI, we are promoting a transparency, and that can develop and help identify and address the potential backdoor attacks at an early stage. So basically, this involves making the model's training data and model's architecture and the decision-making processes accessible for scrutiny and evaluation here. So the entire like operations is being completely transparent, and which makes the model training much more easier and the decision-making processes much more secure, and makes the evaluation of the model in in a robustness, complete full secured and robustness. That's called like a verifiable AI and transparency in it. So let's jump into what all the implications of like backdoor attacks. So basically, they are like a three different implications of like our backdoor attacks. They are like misclassification, we can tell, and next is like privacy leaks of our data, and next is like DOS attacks. So DOS attacks is called like a denial of service attacks. So let's jump into like each and everything. So the first one is a misclassification. So when The attacker can force a model to make incorrect predictions for the graph containing the backdoor trigger. That's called like a misclassification. Our classifier is being compromised here, and it leads into like different kinds of like predictions. So it's completely out of box for us. So that's the misclassification of backdoor attack. So next important thing is like the privacy leaks. Here the attackers can exploit the backdoor to extract the sensitive information of the users, or like sensitive information of the training data or the input graph data here, so that the attackers can directly attack the individual persons who is being trained, or the model what for what the purpose is being trained here. That's the biggest like a problem here. So next important thing is like denial of service attack. The denial of service attack is like attacker can make a trigger that the backdoor caused the model to crash, or it can perform poorly completely. That's called like a denial of service attack. So these are all like a basic implications of a backdoor attack which we can see. So next is like our like now we have like our hands-on session. So I'll be making a different breakout rooms now, and we're gonna build a boat. Like last week we had like installed our Neo4j with Python drivers, Langchain drivers we did install, and OpenAI like different libraries we did in like install here. In this week we're gonna make like some bot, chatbot kind of, which can interact with our OpenAI with integrating our Neo4j. And by this, we can ask a query to a chatbot, and it connect automatically to like our LLM, and then it retrieves and gives us the different set of queries for a specific Neo4j data. So let's jump into it, and I'll be giving like a personal like monitoring as well in this.